This is the last of kinds of logarithmic equations that we did in class. In this problem, we're going to have to use our properties that we learned to be able to work the equation. On the left-hand side of the equation, we have two natural logs. We need to figure out some way to turn that into one natural log. And we know from our properties that subtraction becomes division. So on the left-hand side, we take the subtraction and we turn it into division. And we have one natural log with a division over here on the left-hand side. In algebra, because we have a natural log of one thing equal to a natural log of another thing, we can drop the natural logs. Now, caution here, you can only do that if you have natural log or log of one thing equal to natural log or log of another thing. We couldn't have done it up here in the first step because we have two natural logs on the left-hand side. It has to be 1 and 1 to be able to do that. Now, at this point, we can turn our problem into a proportion and cross multiply. When we cross multiply, we get x, because this 3 has a 1 under it. X times 1 is x, and 3 times x minus 4 is 3x minus 12. If I bring x to the other side, I get 3x minus x equals 2x. And the minus 12 to the left-hand side, that negative 12 becomes a positive 12. I can now divide both sides by 2 and get an answer of x equals 6. Now this one is also important that you take this answer of 6 and plug it back in. You cannot take logs or natural logs of negative numbers, so you want to make sure that you're taking logs or natural logs of positive numbers. I can put a 6 here, and it's perfectly fine to take the natural log of 6. If I put a 6 here, this becomes 6 minus 4, which gives me 2. That's also a positive number, so that would be okay. If either one of these were a negative, I could not take the natural log of that number. The answer would be void, and this problem would have no solution.